Hello, class. We're about to go over section 2.1 and 2.2. I'm going to go over the problems 1, 3, and 9 from 2.1, and then 1, 5, and 9 from 2.2. All right, and before we get started, just as a reminder, your exam 1 is due October 4th, and also with your exam, it does have respondents on it now, and then you get 2 attempts, and it does not have a password. So you have the date. You can go right to My Math Lab and go ahead and do the exam. All right, so problem number 1 from 2.1 actually starts on page 189. So we would do 1A. It's actually 1A through K. So it says you are a financial planner in an effort to attract new customers. You sponsor a dinner at a local restaurant. The restaurant will charge $100 for the banquet room plus $12.50 per person for each meal. You will pay these expenses yourself. From past experience, you can expect to make sales to approximately 15% of the people attending. You also know that the average sales you can expect from each new client is $750, for which you receive a 13% commission. It is clear that your personal financial success from the event depends on how many people you can attract to this dinner. All right, so you are given a table. All right, so we'll do X, and I'm not going to write out everything from the table because you have your textbook. But this X represents the number of people attending, and then this here would be the cost of the banquet hall. I just put BH, and then the total meal cost, and then finally the total cost. So you have 20, 40, 60, 80, 100. These are the amount of people that's given to you that will attend. So now you have the first value. Well, I don't need to write that because it's in hundreds of dollars. So the cost of the banquet hall, it doesn't matter how many people you invite, it still would be $100. That's how much it costs for the banquet hall. So all of that will be 100. Now, the total meal cost. Now for 20 people, now remember it's $12.50 per person. So well, I guess we could do this on Desmos. So first of all, we will have 20 times 12.50, and that gives us $250. And then next we would do 40, then 60, and so on. So then 80, and then finally 100. Okay, now the total cost, we will add up each one of these rows here, the cost of the banquet hall and the total meal cost. So this would be 350, 600, 850, 1100, and 1350. Okay, so now that will complete the table. Now we go over here to B. It says determine a formula for the total cost of restaurant expenses as a function of X, the number of attendees. Represent the total cost by C of X. So we know we'll have C of X is equal to, now we're told that it's $12.50 per meal for per person, plus $100 for the cost of the hall. So now we move on to C. It says if 20 people attended, determine the number of new customers. Now remember, it was told earlier that he could just, if we go back to the reading for number 1, it says that you can expect to make sales to approximately 15% of the people attending. So you would take your 15% right as a decimal and multiply by the 20 people attending, so you only expect 3 people to become clients. Okay, D, determine the total sales of the new customers in part C. Now it's told here back in the reading for number 1 that you would make about $750 per person. So that would be $2,250. Now E, this is how much you would take home in commissions, 13%. So it'd be 13% of the $2,250, which would be $292.50. Now it says complete the following table. The results from C, D, and E are recorded. All right. So we have to do another table here. Now it's nice and convenient in the textbook. So this is the number of people attending. This is the new customers or number of new customers. And then this will be total sales. And this here would be the commission. So we'll go anywhere from 20 to 100. All right. So now, new customers out of 20 would be 3. That's what we got from C. So we'll take 15% of 40, which would be 6. And then I'll just show how you would do this in a calculator. It'd be 0.15. Let's do times 60. And then that will give you 9. And then times 80 would be 12. And times 100 would be 15. Now total sales, it was 2250 here. Because we'll do 750 times how many are your new customers. So then we would do 6 times 750, just 4,500, 9 times 750, and so on. Each one of these numbers here will be multiplied by 750. All right. So now your commission. Now remember, your commission is 13% of total sales. So this here would be $292.50. This would be $585. Well, I don't need to put the dollar sign. This would be $877.50, $1,170, $1,462.50. Okay, now this was F. Now we go here to G. It says determine a formula for the total commission that you can expect to generate from this dinner as a function of X. The number of attendees. Represent the total commission by T of X. So we will add T of X, and we know we made 13% off of total sales. So we know, 13% off of total sales. So we know we expect every client we get to spend $750, and then it's 15% of X. So it's 15% of the total people that attend will tell you how many clients you have. How many clients you have will be multiplied by the $750 you expect them to spend, and then you make 13% off of that. So this here would be 14.625x. Okay, now, if you want a quick breakdown, this right here would be your commission. And this right here would be your new customers. Okay, now we move on. We will go here to H. So H, it says combine the formulas in part B and G to define a new function for the profit P that you can expect from the dinner. A basic business equation is profit is equal to the revenue minus cost. All right, so we'll do P of X is equal to T of X minus C of X. Now remember, T of X we got in G, and then C of X we had got in B. So T of X is 14.625X minus C of X, which is 12.50X plus 100. Now, when you put this together here, this subtraction would change the sign of everything inside this parenthesis. So you have 4.625X minus 12.50X minus 100. So we like to combine like terms here. This will give us 2.125X minus 100. Now, we go to I. What is the practical domain of this new function? Okay, the practical domain, we know we're not going to end up with a negative number here. So it'll be 0 is less than or equal to X, which is less than or equal to the number of people the banquet hall will accommodate. All right, now J. It says use your new function to determine how many people must attend for you to break even. Now, our new function is P of X is equal to 2.125X minus 100. Okay, now, the break-even point is where you don't lose money, you don't make money. So you basically have a 0. Okay, does everyone still hear me?
Yes. Yeah.
Okay. All right, I was just making sure because I just saw a message here that said, oh, okay. Okay, good. Okay. So now, again, breaking even is where you don't make any money, you don't lose any money. So that'll be 0. So you would set this equation equal to 0. Now we would solve for X. So we would add 100 on both sides. So 100 is equal to 2.125X. We divide each side by 2.125. And we know this will be an approximation, most likely. So we would take 100 divided by 2.125. And that'll be approximately 47.06. Now, we cannot have 0.06 of a person. So in order for us to break even, which will actually take us over a little bit, 48 people must attend. So it's 48 people must attend. Anything below that, we have a loss. Okay, now K. It says you hope to make a profit of $500. Okay, I was asked how did I get 48? Okay, because this is over 47. Remember, we cannot have 0.06 of a person. We want to know where we will break even. So you either use the exact number you have or you would go higher. if you use 47 instead of higher than 47, you won't break even. You will actually be at a negative. So that is why we do 48. Did you follow that? Okay, I see.
Yes, I got it. I didn't realize you went ahead and solved for X. I thought you were still talking about 2.125 not being a person, or so I got confused.
Oh, okay. Okay.
That makes sense. So you just round it.
Not rounded, you just go up. Because if I would have rounded, it would have just stayed 47.
Oh well, yeah, yeah, true.
Right. Okay, so it says here you hope to make a profit of $500 on the dinner. How many people must attend for you to meet this goal? Okay, so basically it's the same formula, but this time P of X will become 500. So we would add 100 on both sides. So it'd be 600 is equal to 2.125x. We divide each side by 2.125, and x will be approximately 282.35. So you need 283 people to attend to reach $500. That is a lot of people. Okay. All right. Okay, so that took care of problem number 1. Now we're going to go down here to problem number 3. It says, suppose that F and G are defined by the following tables. So they give us these tables here. Now it says, complete the following table. Okay, so I'm going to write out the table we have to complete. So we will have X, and it'll be 0, 2, all the way to 10. Oh, I might have made that a little small there to 10, but hopefully it's not going to be large numbers. Okay, so now we will have f of x plus g of x, and then f of x minus g of x. All right, so we need to find out what these formulas are. So if you look here, if you look back at number 3, we go 0 through 10. Now, of course, you're going to need to look in your textbook. But let me see something here. See if I could pull out the textbook here. All right, this is number 3. We have 0, 3, 2, negative 5, 4, 0, 6, 7, 8, negative 1, and 10, 4. All right, now, if you notice here, it says, suppose that F and G are defined by the following table. Now, if we look here, we can see if we see some type of pattern here, which it really doesn't look like we have a pattern here. But this is what I'm going to do. We could actually put this in a table in Desmos and find an equation to see, well, actually, we don't need to do that. I'm sorry. I forgot we're not at that lesson yet. So let me show you what we need to do. We're actually at the best lesson here, which would be this here. The f of x plus g of x, we'll take f of x, which is 3, and g of x is 1. So we will have 3 plus 1, which would give us 4. And then f of x plus g of x, that'll be negative 5 plus a negative 1, which is negative 6. Now, I'm not going to write all this out each time, but we see 4. We got f of x is 0, g of x is 1. So that'll be 1. 6, that's when our x is our 6. This will be 7 plus a negative 1, which is 6. Then we take 8, negative 1 plus 3 is 2. Then we take 10, 4 plus 4 is 8. Now we come here, f of x minus g of x. F of x minus g of x, 3 minus 1 is 2. Negative 5 minus 1 will give us negative 4. 0 minus 1 is negative 1. 7 minus a negative 1 is 8. Negative 1 minus 3 is negative 4. And 4 minus 4 is 0. So that's how we would fill in the table. All right, that was number 3. Now we go here to number 9. I said I would do 1, 3, and 9 from 2, 1. Okay, suppose f and g are defined by the following tables. It says complete the table. All right, it's basically the same thing here. All right, so we need to do a table here. So we have x, negative 6, negative 4, negative 2, 0, 2, and 4. And then I believe we only had one more. Yeah. So we had f of x minus g of x. All right, so now we'll go here, f of x minus g of x, 50 minus 49 is 1. 16 minus 25 is a negative 9. Negative 2 minus 9 is negative 11. Negative 4 minus 1 is negative 5. 10 minus 1 is 9. And 40 minus 9 is 31. And that's basically it for 9A. Now, we're going to move on to 9B. With 9B, it says if f of x is equal to 2x squared plus 3x minus 4, and g of x is equal to x squared minus 2x plus 1, determine the algebraic expression for f of x minus g of x. All right. So f of x is 2x squared plus 3x minus 4. Well, let me write this out. F of x minus g of x is equal to, the f of x would be 2x squared plus 3x minus 4. And then it'll be minus g of x. G of x is x squared minus 2x plus 1. So we had 2x squared plus 3x minus 4. And this minus sign here would change the sign of everything inside this parenthesis. So it'd be minus x squared plus 2x minus 1. So we have f of x minus g of x. 2x squared minus x squared is x squared. 3x plus 2x is 5x. And negative 4 minus 1 is negative 5. So this right here would be your final answer. Okay, now it says check your answers in the table in part A by using the function you determine in part B. Okay, so basically what they want you to do is substitute these values in here. So if I put in negative 6, as a matter of fact, why don't I do this? I think this would be a little easier. If we put the equation in Desmos, so we got y is equal to x squared x squared plus 5x minus 5. Oh, Okay, I made a little mistake there. Let me see, x squared minus or plus, let me go back here, plus 5x minus 5. Okay, so we have the equation here. We click on this wheel here and click the table. So all we need to do now with this table here is just type in these values. We have the 0 and 2. 0 is -5 and 2 is 9. But now we need the -6, the -4. Oh, we also have the -2. And then we have, what's that, the 0. And now we have 4. So all of these answers check out. All right. So now we move on to 2-2 on page 201. So I said I was going to do problems 1, 5, and 9. So problem number 1, it says you are drawing up plans to enlarge your square patio. You want to triple the length of one side and double the length of the other side. If X represents a side of your square patio, write an expression for the new area in terms of X. Okay, first of all, you have to know the characteristics of a square. A square says all the sides are the same. So if we're doing everything in terms of X, and we know with area, we multiply length times width, we know we're going to have an X in both of these parentheses because those sides would be the same length here because they're a square. Now they said they want us to here, we want to triple the length of one side, so 3 times that one side, and double the length of the other side. So we had 3x times 2x, which is 6x squared. So that's basically it, the new area in terms of X. KB, it says, okay, it says you discover from the plan that after doubling one side of the patio, you must cut off 3 feet from the side to clear a shrub. Write an expression in terms of X to represent the length of this side. So the side that's double, you got to cut off 3 feet, so you're going to subtract 3. Now it says for C, use the result from part B to write an expression without parentheses to represent the new area of the patio. Remember that the length of the other side of the original square patio was tripled. So our side is 2x minus 3, and it's still times 3x. So we'll take this 3x and do the distributive property. That'll give us 6x squared minus 9x. So this will be our answer in terms of x. Now, I believe the next problem I said that I would do was problem number 5. Okay, number 5 is at the bottom of page 202. It tells us to multiply x plus 3. It says x plus 3 times x squared plus 3x minus 5. It says determine the appropriate products to complete the chart. Combine like terms and write the final answer for this multiplication in descending order of the exponents. Okay, so they give us a little table here. So at the top we had x squared, we had 3x, and we had -5. Now on the side we have x and 3, and we have x cubed here, 3x squared here. So what this is saying is we're taking x and multiplying it by each one of these values. So x times x squared is x cubed, x times 3x is 3x squared, and x times a -5 is -5x. Then we would do this for 3. 3 times x squared is 3x squared. 3 times 3x is 9x, and 3 times a -5 is -15. So If we wrote this out here, this would be x plus 3. And this up here would be x squared plus 3x minus 5. And using the values we have here, we will have x cubed plus 3x squared minus 5x plus 3x squared plus 9x minus 15. And then we would combine the like terms, x cubed, we have a 3x squared and a 3x squared, which would be 6x squared. Negative 5x plus 9x is a positive 4x, and then minus 15. All right. Now we look here at number 9. Now number 9, A, it tells us to expand 2x plus 3 parentheses squared. So this is just 2x plus 3 times 2x plus 3. And we can use the distributive property. Some people call it FOIL. But we would take this first value times this first value. And then this first value times the last value. And then we would take this last value here times the first value. And then this last value times the last value. Now these plus signs that you see, they came from the sign of these two values that was multiplying here. So this would be 4x squared plus 6x plus 6x plus 9. So this would give us 4x squared plus 12x plus 9. So this would be the final answer for 9A. 9B, we have 3x minus 2 squared, which would be 3x minus 2 times 3x minus 2. And we follow the same procedure. So it'd be 3x, I'll put parentheses this time instead of the dots, plus 3x times a negative 2. Then minus 2 times 3x, and minus 2 times negative 2. So this would be 9x squared minus 6x minus 6x plus 4. So it'd be 9x squared minus 12x plus 4. Now we go to C. We have 5x plus 2 times 5x minus 2. Now listen, this is a binomial multiplied by a binomial. If you have the exact same things inside these two parentheses, and they're binomials, but one is a plus and one is subtraction, you can multiply the first times the first and the last times the last. So that'll be 25x squared minus 4. And that would be your answer. But I am going to show it expanded. That's the answer. But if we expanded it out, it'll be 5x times 5x plus 5x times a negative 2 plus 2 times 5x plus 2 times negative 2. So this would be 25x squared minus 10x plus 10x minus 4. These 10x will simplify out, and you'll be left with 25x squared minus 4. Okay, now we come here to D. So we have D, E, and F, and then we are done. D is x squared plus 5 and x squared minus 5. We can do the same thing we just did. Exact same, except for one is addition, one is subtraction. So we do the first times the first, x squared times x squared, and then the last times the last. So this will give you x to the 4th minus 25. Now, if you want to multiply it out in expanded form, feel free. Now, E, we have a triple here. We have x plus 4 to the 3rd power. So this is the same as x plus 4 times x plus 4 times x plus 4. Now, let me ask you all a quick question before I multiply. What is the most amount of values that you can multiply together at one time? Anybody?
Is it 3?
You're very close. close. It's only 2. No matter how large or how small the values are, the most you can multiply at one time is 2 values. So using that, I would suggest that we multiply 2 parentheses first, get that value, then multiply by the third parenthesis. So we have x times x plus x times 4 plus 4 times x plus 4 times 4. Now I'm not doing this third parenthesis yet. So this is x squared plus 4x plus 4x plus 16. So this would be x squared plus 8x plus 16, and then I'll bring down the third parenthesis. So now we can multiply everything out here. X squared times x plus x squared times 4 plus 8x times x plus 8x times 4 plus 16 times x plus 16 times 4. I ran out of space. So this would be x cubed plus 4x squared plus 8x squared plus 32x plus 16x plus 64. Now we combine the like terms. It'll be x cubed, 4x squared, and 8x squared is 12x squared. 32x is 16x is 48x plus 64. And that is the final answer. Now F, it says at the simplifying part C and D, the product contains only 2 terms. Explain why. Okay, basically, the final answer is the difference of 2 squares. Hold on, I have a hand raised. Yes.
That last one is supposed to be x cubed, right? Not.
Oh, yes.
Is that
I'm
x?
sorry. Yes, x cubed.
Okay.
Yes, x cubed. Thank you. Okay, now with F. Okay, it says as a simplifying in part C and D, the product contains only 2 terms. Explain why. Now, when I did C, I showed you why, because the 2 values in the middle simplify each other out. So we could say that the outer, this would be F, the outer products, well, the outer product and inner product are opposites. Their sum is 0. That's how we end up with two terms. And that basically concludes 2-1 and 2-2. Did anyone have any questions? Okay.